Hello, today we're going to solve the equation dp over dt is equal to t squared p minus p plus t squared minus 1. So I've had a lot of difficulty in my college years of solving differential equations and finding the solution, and it seems like there's a lot of paths to failure and only one or two paths to success, and it's hard to get down the process and look at this intuitively and know what the first step is in order to solve the equation. So me personally, when I look at this differential equation, I look for common factors in it, and I see that there are t-squareds. So I'm going to try and group those t-squareds together and see if there's not anything that comes out that I can do next with those. So if I rewrite this as dp over dt equals t squared p plus t squared minus p minus 1, I look here and I see that I can take t squared out of these two factors and might be left with something worth value. So if I take t squared out, I'm left with p plus 1. And I can see over here that I have a negative p minus 1. And if I took out a minus 1, I'd be left as well with a p plus 1. So I will do that over here. This is the equivalent of saying I see that I have a p plus 1 here and a p plus 1 here. So what I can do next is it's the equivalent of saying t squared minus 1 p plus 1. And if I ever am in doubt of if this is a correct point that I'm at right now, I can just FOIL this. I can say t squared p. I have that here. For the first, the outside t squared, I indeed have that there as well. Inside is negative p, and outside is, or excuse me, the last is negative 1. So that is indeed an equal representation of this. So the next thing I can do is group variables together, and I'll do that now. I can go dp over p plus 1, that is a p, is equal to t squared minus 1. I'll keep these in variables for safekeeping. dt. I multiply both sides by dt to remove the dt from the bottom here and move it to the other side. And likewise, I multiplied both sides by 1 over p plus 1 to remove it from this side. So at some point you have to integrate a differential equation, and this is no better time than now. If I look on integral table, my form back there was 1 over p plus 1, so I'll use this right here for my p variables, and I can use this form here for my t variables. Integrating that, I am left with the natural log of the absolute value of p plus 1 is equal to 1/3 t cubed minus t plus c. I need the c here because these are indefinite integrals. So a c is very customary and necessary when you have that. The next thing I want to do, this is dp dt. This whole equation is dp over dt. So at some point, the end game is I need some equation p equal to some equation. And right now p is in natural log and there's an absolute value around it. So in order to get rid of that, I need to put both sides up by the power of e. And I choose e because the natural log is just the log of e. And when you have a log of base 2 and you put it to the second power, or base 10 and you put it to the 10th power, it wipes out the log. And this will wipe out the natural log. So doing that, I'm left with p plus 1 is equal to e to the 1/3 t cubed minus t plus c. And this can actually be rewritten as p plus 1 is equal to e to the 1/3 t cubed minus t, and I can put out this variable c. This is the same as saying e to the c. If I wanted to recombine this, I could just as well put c back up here. But I do that so that I can have this variable k equal e to the c. When you have your professor on an exam, they're going to want you to have this e to the c represented by k, or likewise any variable with c represented with k, just to make it look cleaner and nicer. And that should be the final answer for it. So if we go on, we have p plus 1 is equal to k e to the 1/3 t cubed minus t. And if we move this 1 to the other side, we are just left with p equals k e to the 1/3 t cubed minus t, all minus 1, where k is equal to e to the c. So this is the final answer. Just be sure when you do this to start following a method, and if you do that same method for every single problem, for every single situation, you'll succeed, and at least your professor, for following the right method, will give you some sort of credit, I promise. So please just try your best on your exams, and like my channel, and hopefully I can give you more content if this helped. Thank you so much.